together, it's more like a solid, isn't it? Okay, and so when they're closely together or very dense, okay, you put a little bit of heat on them, and those molecules just barely move around, right? So they're becoming more like a liquid state, okay? Okay, same kind of thing with density, all right? Then when you turn the heat on really high, that's gonna come more like a gas. Okay, so again, it's just another visual of these molecules being packed closely together, okay? All right, so let's layer out our liquids really quickly. So obviously you can see that they have separated out pretty good, okay? This is the water. It still has some of the soap in it because it kind of caused bubbles. And then you can see the oil, and then on top you can see just a really thin layer of the alcohol, okay? So let's go ahead and label them. Bottom was the Karo syrup. All right, and I'm gonna tell you the density of each one of these. I've looked them up. I'm not just making these numbers up, and then I want you to write them down. So the Karo is actually 1.37 grams per milliliters. Make sure you're labeling them each one. Okay, on top of that we put the dish soap. So we put the soap, all right, and it was 1.03 grams per milliliters. All right, then on top of that we had the water. All right, and this is, I'm doing this in different color because this one's pretty important. You have to remember the density of water. Okay, it's pretty easy, it's 1. Okay. All right, on top of the water, we had the oil, which was 0.91. And then we had the alcohol, which was 0.87. All right. Now, looking at those numbers, I want someone to come up with a conclusion here. What can you conclude from these numbers and the way these layered themselves out? Okay, Sarah Lynn?
The densest one is on fire.
What do you mean the densest one? The one with the highest density? Yeah. Okay, so she says that they increase in density as they go down. Does everybody agree? And so that means as they go up, they what? Decrease. So the least dense layer is on top. All right, very good. That's exactly right. The more dense they are, the more compact they are, they're going to be towards the bottom. Okay, what can you also say about water? Things that are less than 1, or water, 1 is water, are going to float, and things that are more dense than water are going to sink. So the rock would be more dense than water, and then this one is, why do you think this one bubbled? It's probably right at 1. Things that are right at 1 are going to kind of bubble, which is why your pencil, when y'all did your pencil measurement, it should have been less than 1 or right at 1, because pencils really do float in water, okay? So let's go back up to this guy, okay? And if we were going to put like a sink or float column over here, what did your pencil do? It floated, okay? Was anybody's under 1? Okay, today we've had a lot of them that were more, they were more like 0.9, okay? So if you'd have done it accurately, it should have floated, all right? Your numbers really don't show it. Your orange, the solid orange, didn't y'all's float? Mm-hmm. Okay, so it should have floated. Maybe your calculations were a little bit off. Again, when you're really close to 1, you're gonna be right there on that bobble stage, yes? Make sense? Okay, and then 1.1, what about your peeled orange? It's sunk a little bit more? Okay, again, these are going to be pretty close because these are right around 1. Today, I've had more like 0.8 and 0.9, and then this one was around these. So these are really the ones I've had today, so then that would definitely be float, and more of a sink. Does that make sense? Okay, and again, this is not perfect measurements of science, but it's as close as we're getting. Okay, you can turn it off, Madison.